So today we have a problem related to perspective. From the perspective of an observer standing still on Earth, we have a ship moving along the equator towards east with a velocity of 30 kilometers per hour. At the same time, southeastern wind is blowing with a velocity of 15 kilometers per hour at an angle of 60 degrees from the equator. For sign convention, the velocity is taken as negative towards west on x-axis and towards south on y-axis. The velocity of ship can be written in vector form as shown. Since it has no displacement along y-axis, its velocity will be 0 along y-axis, whereas the velocity of wind will have its components along x and y-axis, having a value of negative 15 cos 60 and 15 sin 60 respectively. The negative sign along x-axis is because of the sign convention. The component along x-axis is the coefficient of I, and the component along y-axis is the coefficient of j. So the relative velocity of wind with respect to an observer standing still on the ship will be the difference of velocities of wind and ship in vector form. By this, we can easily get the value of relative velocity along x-axis and y-axis as the coefficient of I and j respectively. After this, we can easily calculate the angle at which the wind will be blowing from the perspective of the observer standing still on the ship. Try looking at the bottom right corner of the video to understand better. So the angle will be negative of 19.1 degrees. Now, the magnitude of wind velocity can be calculated with respect to the observer on the ship, and we will get a value of approximately 40 kilometers per hour. For better understanding, you can click at the bottom left corner of the screen. The diagram can be redrawn from the perspective of the observer on the ship, and in this case, the observer on the ship will experience the southeastern wind blowing at a velocity of 40 kilometers per hour at an angle of 19.1 degrees from the equator. Thanks for watching, and don't forget to like, share and subscribe.